All right, in this segment, we're going to seal a glass sphere. A little more difficult than doing the polyamide, which has got that single O-ring in it. But glass is really a wonderful substance. It works really well, high strength under compressive forces. We've used them all the way to the bottom of the Mariana Trench, Atacama Trench, Puerto Rico Trench, Aleutian Trench, all over the place. So this is a 10-inch sphere. It's rated for 10 kilometers. Which is satisfactory for a lot of trenches, but certainly if you're going to 6 kilometers, 10 gives you a lot of extra meat. So the thing to be really careful about with glass is that it's very brittle in terms of its ability to shear. If you smack it on the side, it'll be like obsidian. It'll just chip off and flake glass, and then your expensive housing is no longer any good. This is made in a plug assist casting operation. Germans do it about as good as theoretically possible, I believe, where they take a tool and put it underneath a pot of glass, and then they drop a blob of glass in there. Then they come down with a plunger, whack, and they squish this stuff up. And so the outside diameter is surface is molded by the exterior larger mold, and then the plunger creates the inside diameter. And how well they align the two center to center creates the wall thickness, uniform wall thickness. If that plunger woggles a little bit, you'll get a thin side here and a thick side over there, and that's kind of a hassle. So the Germans have done it where they have a very uniform wall thickness, so that's pretty nice. One of the dangers of glass, though, is it's not very strong. It is very strong in compression, but its tensile strength is not good, and it's really easy to chip this stuff. So we have to be very careful. That's why we use that soft rubber bumper on here to keep it from whacking into something and chipping off. So yeah, so let's proceed to clean this and clean this. You can drill glass with a diamond drill. That just bores right through. And then they spot face it to put a flat on there so we can use a standard O-ring seal. Drilling glass is actually really difficult, and really one of the reasons is you can go through halfway easy enough, but when you get to the very end, it blows out on the backside, just blows out with a giant spall. And there's a technique you have to go through to drill from two sides. Long story, but if you can get the Germans or the manufacturers of your glass to do that, I recommend doing that. Can't thread it, just gonna be a clearance hole. So when we put things in here, we have to actually put a retaining nut on the inside and essentially clamp this thing against the outside surface of the glass. So here we have 3 through ports. One is a connector, electrical connector from Subcon. It's a low profile right angle, which is kind of nice. Cable plugs in here, runs off somewhere. This is a purge port. This is a purge port. This is a PRV, pressure relief valve. This one's made by Prevco. Got a couple of seals on the inside, primary use for this one is if there's a high pressure on the inside, this will lift off and just blow the excess pressure out. If you think of a hatch like on Captain Nemo's 20,000 Leagues Under the Sea, you want the door and the floor, like an undersea habitat. So when you're deploying this thing, you want the purge, this PRV on the bottom side. This is a purge port, so we're allowed to screw onto here. It allows a free two-way flow of air. I would use this for that. Some people try to use this for a purge port. I don't recommend it because there's 2 seals on the inside, and it is possible to lift this thing off with a special little adapter that goes on there, opening it up for a free flow of air both ways. But that air is flowing back and forth across 2 seals, and there's no way to inspect those seals, and that air might be carrying lint or dust or a little bit of solder splatter or something else, and there's just no way to guarantee that it won't land on that O-ring. There's just no way to guarantee it. So yeah, and if you do that, then you just have to check to see. You can hold it open and see that there's a vacuum leak check on this thing, but it doesn't test those final 2 seals. So you can do that with this though. And the purge port, so if you leave that one shut, leave it alone, leave it for what it's supposed to do, vent over pressure from the inside. This guy here, when you screw onto it, it opens up a little check valve. Now you open up a free flow of air. You pull off the adapter plug that fits on here, and now that thing seals and holds off a maximum differential of 10 psi from outside to inside. So now you have a chance to clean this, you know, pull out the O-ring, inspect it, make sure everything's fine and clean, and you know, and in fact, you could walk away and go to lunch or answer the phone or something. That thing's going to stay solidly sealed until you know, until you're done, and then we just put the pressure-proof cap back on. Again, that pressure check valve on the inside is only good for 10 psi, so you have to push this check valve on, or I'm sorry, this pressure-proof cap over that. Now this assembly here can be tested to, well, we've tested them to 18,000 psi, so you'll have no problem going to the bottom of the Mariana Trench. This will only go to 10 kilometers, but these go to past 11. So having said that, we're going to clean these, put it together, seal it up. So now let's turn this over. This I'm going to put in this little wood stand, makes it a little more stable. You just see that this is a 10-inch sphere. That's about a 9-inch hole. That's about a 12 by 12 piece of plywood. A couple of, you know, 2x2s here in the corner. Very cheap to make, but it works really nicely. And the wood is nice against the glass. No danger of hurting this. So let's take the rubber surface, you know, the protective rubber ring off of that. And then we're going to clean this. And you want this just absolutely clean. There's no oil that goes on here. We want no lint. We use Kim wipes, which are a lint-free cloth. So we don't leave anything behind. There's another one over here. These are just amazing. It's like an apothecary jar with a plug. Sealing these things up. Again, we're being very careful because the glass is so brittle. The nice little squeaky sound is let you know that you did a good job of cleaning it. Okay, then we're done with that one now. I'll take this off. Expose the purge port. Now we have our little adapter, and inside is a small little fitting probe that pushes open the check valve, kind of like a bicycle tire. And we just run it down, and inside this fitting, there's a rubber seal that rests across the top of the check valve, so it makes an airtight seal. So we make sure that these are aligned, you know, well. You can just feel it, and then pull a vacuum on this thing. Turn over vacuum here, and we'll go ahead and draw a vacuum. And you see the gauge is ramping up here. So the air pressure is holding it together now. But the real low pressure seal is going to be this guy. So at some point we want to kind of just keep an eye on that. A lot of electronics do not like to go beyond about a half an atmosphere. We have a diaphragm pump on the inside which takes you about 0.7. So we're going to put it right there and just let's do a hold on it. You can see it's actually sitting pretty tight. If it was leaking that, this thing would be migrating back to 0. So now we're holding a vacuum here. We're now going to take this soft butyl rubber, and this will be the low pressure seal that we put right across the equatorial interface between the two hemispheres. And it's wide enough that we can be off a little bit, up and down, but we do want to cover that interface. So let's see, that's holding very well. So I'm going to actually go ahead and take this off. Turn this off. I'll put that on just because we can. And then this guy, we're going to take it around the outside and cover that little point where the two hemispheres engage each other. Like that, okay? And we'll cut that a little long. And we peel back this paper, this wax paper. and overlap these. So now they overlap right there. So we brought this around. And now what we want to do is we want to run around the outside of this thing kind of lightly and just sort of press that against the glass. And what we're going to be doing is right at the interface between the two hemispheres, there's a little bit of a chamfer, not much, but just a little bit. And we want to run this around and press this soft butyl rubber into that chamfer right at the seam. And that's going to create the low pressure seal. Okay. And this little roller here comes from, I think it's from wallpaper. There's better ones and there's cheaper ones, but I'd go for the better one. And we just run it around the outside. Down, just make sure that it's adhering to the glass really well. This is an architectural butyl rubber, and it's fairly inexpensive stuff. So you can afford to bring a lot of it with you. Then what we do is you find where the seam is, and go ahead and just pull back that paper. Kind of like that. There you go. Now you can see that it's actually done a pretty good job of hitting it right there on the center line. That's what you want. Then the final step, though, is then we use this 2-inch black tape. And that becomes kind of a protective layer. So if this is our low pressure seal, we just want to be sure that that doesn't get scraped away accidentally. So let's put on some of this black tape. And we take it around. Then we overlapped a little bit. Sort of the accepted standard by those of us who have done this for so many years is to go around once right on the center and then drop down and do once, overlap it 50% that way, then 50% that way. So it takes three circles. All right, so that's that one. And more to the top. Clip that off. There we have it. So you can see the butyl rubber right down the middle here. And there's a few wrinkles in the black tape, but that's all right. What we're trying to do is just make sure that we can't scrape this butyl rubber off. So we're sealed. So now what we do is we've got the ability now to go back and purge this thing. So let's take this off again, attach our fitting. There we go. We're still sitting pretty nice on the vacuum. So now we can go ahead and just cycle it. So what we'll do is take her down. See the valve, the gauge drop in here as the vacuum draws air in over the desiccant. So now that dry air is going and turbulating and lowering the dew point by lowering the moisture content. So we'll do that once. Now we'll take it back to vacuum. Again, it's the rule of 3 or 4 if you're going deep. Very cold. We're just being safe. A half an atmosphere. Good. And now housing interior pressure. That's actually the vacuum leak test. And we're testing everything except that very last seal right there. Yep, so it's sitting rock solid, not moving at all. So I think all the seals are good. So let's go ahead and take it back to desiccant one more time. Pressure, interior vacuum dropping down as exterior atmospheric pressure is pushed back in, pulled back in by the vacuum. And then the last time, we'll just take it down the third time. So we're at 0.4, there's 0.6, 0.5's in the middle. So we're right in there. Set that there. Remove our adapter fitting. this off. And now that check valve is sealed, giving us time to, inspect and clean the final O-ring. It's always the last guy. The vacuum leak test will check everything else, but it can't check that. So that's really just, the care of the individual that's sealing it up. And so we just make sure there's, it's clean, that's clean. Just clean the O-ring a little bit, make sure there's no debris on that. Sometimes I give it a little tug test as I go around to make sure there's no cracks or splits or cuts in the rubber. And then we use a little bit of typically a Dow Corning high vacuum grease. It works really well with the Buna O-rings. So we put a little O-ring grease on there, and then we just make sure that the O-ring itself is completely lubricated in all surfaces. And then we go ahead and place it into the cap. So O-ring, the grease, the silicone grease, has no shear strength, so it doesn't provide the major seal. It just allows the O-ring to move around a little bit, slip around. Under pressure, it seals up against the inside surface. So very light coating is all you need. And too much is not good. Then we screw that on, and again, we just put a little torque on it, but not much, just enough to feel it. You can just sort of feel the two, as you're running it down on the thread, you'll feel the metal surfaces come together and the O-ring squeeze. But that's all you need. You don't need. In fact, I can do this finger tight, and I've done it. We've done finger tight in our pressure chamber, and we've run them to 18,000 psi. So finger tight works. I just give a little nudge past that, but not a whole lot.
This sphere is ready for sea.